Alright, we're continuing on with section 13.3, concavity. This is problem number 20. We've got y equals 1/10 x to the 5th minus 1/4 x to the 4th. That is wrong. I'm writing the wrong problem down. It's actually 1/10 x to the 5th minus 3x cubed plus 17x plus 43. So we want to first get the second derivative. So let's take the first derivative. 5 over 10 is going to give us 1/2. So x to the 4th over 2 minus 9x squared plus 17. That's the first derivative. The second derivative is going to give us 4 over 2. That's going to give us 2x cubed minus 18x. Alright, now we need to set this equal to 0 and find the candidates for points of inflection. Let's factor out 2x. We're left with x squared minus 9. That factors further into x minus 3, x plus 3. So we have three potential candidates for points of inflection: 0, 3, and negative 3. So let's set up a sign chart. So negative 3, 0, 3. We have the interval between negative 3 and 0. We have the interval between 0 and 3. We have the interval from 3 to infinity. And we have the interval from negative infinity to negative 3. Alright, let's examine the various components of the second derivative. 2x, x minus 3, and x plus 3. And of course, these components will tell us what the sign of the second derivative will be over the given intervals, and ultimately the nature of the graph, the original function, over the given intervals. Okay. So starting with the first interval, let's plug in negative 4. 2x times negative 4 is going to be negative. Negative 4 minus 3 is negative. Negative 4 plus 3 is negative. A negative times a negative times a negative is negative. That means that the second derivative is negative, implying that the function is concave down over the given interval. Alright, let's plug in now between negative 3 and 0. Let's plug in negative 1. Negative 1 times 2x is negative. Negative 1 minus 3 is negative. Negative 1 plus 3 is positive. Negative times a negative times a positive is positive. So the function is concave up over that given interval, and negative 3 is indeed an inflection point. Alright, let's look at the next interval between 0 and 3. Let's plug in the value of 2. 2 times 2x is 4x, which means that this is positive. 2 minus 3 is negative, and 2 plus 3 is positive. So we have a positive times a negative, making the second derivative negative. And so the function is concave down over that interval. And again, because the concavity changes as the function passes through 0, we have another inflection point at 0. And finally, let's look at the final interval from 3 to infinity. Let's plug in 4. 4 times 2 is positive. 4 minus 3 is positive. 4 plus 3 is positive. So the second derivative is positive. That means that over the final interval, the function is concave up, and again, as the function passes through 3, the concavity of the function changes, thus making 3 another inflection point. So we have inflection points at -3, 0, and 3. And that is it. We are done.